All right, so now let's continue. So this one here, what you need to understand, equilateral triangle, you already know the angle here. The angle are all 60 degrees. Am I right?
Yes.
60 degrees here, and then 60 degrees here, and then also here 60 degrees. Now I'm just gonna do, just to explain roughly, if they say what is the electric field, I mean the net force or electric field, it doesn't matter, on A. Remember I told you all these questions they're asking you, the electric field will be pointing in the same direction as the net force. I'm talking about net electric field. I get it?
Yes.
All right. If they say on A, first you look at A and B. Ignore that one. You say, what is B doing? Go A. B will repel A. Am I right? Ne? That means B will push A away. So which means, let me just use something that has an arrow. So that means B will push A in that direction. Can you see that? Then what will C do to that one? Yeah, it will attract that one. You're absolutely right. So which means the other force will be coming this way. Can you see that? Then you can do head to tail method, or what do you call it, parallelogram method, ne? Yes. Because if you try to complete the parallelogram, let me use a different color. Let's just go bluish. Then if I'm trying to get something that looks like this one, that bluish, which means I was going to have a line which is more like this, and then the other one, it was going to go like this. So which means the yellow line like this, it was going there, is going to be resultant. But they won't give you, Luna, this one. I'm just telling you. They'll give you this one, a straightly a right angle. Okay? This one, hardly will they give you. But they give the grade 12. Okay? Yeah. I'm just giving you how it's going to look like. All right? Then, just because you're like, how will it look like? How about if we're looking at B? The resultant could be A will push B away. Am I right? Ne?
Yes.
That means it will go in that direction. What will C do? It will push it in that direction. So which means here, this one that's dancing, that will be like the resultant. Can you see? Yeah. All right. And then how about same thing, Lily direction, yeah, electric field. It will be the same thing. Let's look at C. What will A do to C? A will pull C upwards. Can you see? And then B will push it away in that direction. There we go. So that means here the diagonal here, the one that's dancing, that will be the resultant force and electric field also there. Okay? So how about here? Let's say we're talking about this one on B. C will pull B that direction, isn't it right?
Yes.
But the what you call A will push it the other way around. Can you see? Then the diagonal, this one, will be the direction resultant. Can you see that? Yeah, because you'll do a head to tail method. Same thing. If I were to look at A, what will B do to A? A will be pushed in that direction to the left. But then C will pull A like this. Come. Can you see? Then if I do the parallelogram, it will be somewhere, I don't know, somewhere like diagonalish in that the resultant when you do head to tail. All right? Then if we're looking at C, C will be pulled upward by B. But then C will also be pulled, can you see?
Yes.
By the A. It will go in that direction. Can you see that? Ne?
Yes.
So if you were to do, it doesn't matter if you do head to tail. You want head to tail, which means, let's say I had this going in that direction, and then I also had something going like something like that. I'm trying to mimic those things like that. Where will be the resultant? You can see where the resultant is from the beginning to the end, something like this, ne?
Yes.
Yeah, because you're going up to the left. So in other words, in our case, it might be in that direction, you know? Yeah. So I'm just demonstrating for now. I'll do the last one. Then let's say we're talking about A on this one. What does C do? I'm talking about C now. What will C do on A? C will pull it out, will push it away. What will B do? Attract. Can you see now? This one are pointing in two different directions. Like how you do forces. You'll say the force on the right minus the one on the left. I get, or left minus right. Then you get resultant. Good. All right. Again, how about the B? The B by A, B will be pulled by A. How about by the green? It will be repelled. Can you see? They are pointing in the same direction. You just add them up. Can you see? Same thing. Electric field is going to be the same thing. All right. How about on C? C by A, it will be repelled. And then C by B, it will be in opposite direction. That means the other force minus the other one. Same thing with the electric field will be like that. Can you see that?
Yes.
All right, good. So that was, let me just show the other one. The other one anyway, there's actually no need to do it because it will be this one, but it will be an isosceles triangle. But let's give it here. Let's just draw an isosceles triangle. So we're having that triangle. I can put a green one there, then I can put a white one there, then I can put a yellow one there, then I can give you this side equals to this side. Then somehow it might happen they give you one angle. Let's just say the angle here at the top was how much can we make it? Let's just say it's 80. And then the bottom one, you know they're equal. Am I right? You're running short of 100 to make it 180. All right, so now you know the sum of an angle of a triangle gives 180. So you're left with 100, which means they will share the 100. This one will be 50 degrees. And also that one will be 50 degrees. And then we can make this one a plus. We can make this one a minus. We can make this one a plus. Then we can have, this is charge A. And then this is charge B, and then this is charge C. Am I right now?
Yes.
So now, if we want to figure out the resultant, let's say we're talking about A, the resultant on A. Let me bring it down here a little bit. There we go. We say, what does B do on A? It will attract A in that direction. What will C do? C will attract also, like that. So that means the resultant will be straight down here in the middle. Can you see?
Yes.
Downwards. There we go. All right, same thing, net electric field. How about on B? B will be repelled by C. It will go in that direction, but it will be pulled, attracted by A. Resultant will be somewhere in that direction there. Can you see that?
Yes.
All right, and then when we're checking on our C, I'm just going to shift it a little bit again, and then we say C by A. C will be attracted by A, and then it will be repelled by B. Resultant will be somewhere aroundish there. All right, so these are the types of questions that come, but for grade 11, definitely 2, definitely 3, definitely that one also. So I'll show you how to do this thing.